A pleasant greetings to all. In this video, I am going to explain how to solve the problems in circuit theory that is already asked in TRB 2017 Polytechnic examination in electrical and electronics engineering. First, I am going to explain the problem 82. This problem 82 is coming under A series. The dependent source shown in the circuit below is option A, voltage controlled current source. Option B, voltage controlled voltage source. Option C, current controlled voltage source. Option D, current controlled current source. Here what is Vs? Vs is the independent voltage source. And what is 6 into I0? This is the dependent current source, because the 6 into I0 is the current source, depends upon the current I0. So this current source depends upon the current I0. So this is the current controlled current source. Next problem 83. For the circuit shown below, V1 and V2 are related as. Here V1 is connected to the positive terminal and this is negative. This is connected to the negative terminal. How to write the equation using Kirchhoff's voltage law? First V1 is voltage rise and then next one is voltage drop, that is 6 into I. Again 8 volt is the voltage drop. V2 also voltage drop equal to 0. So V1 equal to 6I plus 8 plus V2. Option A is the correct answer. Next problem. Consider the following statement with reference to parallel resonance. Either series or parallel resonance. What is the condition of resonance? XL equal to XC. Inductive reactance equal to capacitive reactance. This is the condition of resonance. What is the resonant frequency FR equal to 1 by 2 pi root LC. First of all, I am going to draw the graph for this resonance. And next axis take F, and here in Y axis you have to take the impedance and admittance. In a parallel resonance, current is minimum and impedance is maximum. This is Z. And what about admittance? Admittance is inverse of this impedance. So this is admittance. Here this frequency is FR. So this frequency F is less than FR. Here F is more than FR. For example, I have to put F is equal to 0. F is equal to 0 means XL equal to 2 pi FL. So 2 pi FL and XL equal to 0. What about susceptance? Inductive susceptance, that is infinity. Inductive susceptance is infinity here. And next, in the similar manner, F is greater than FR, I have to take FR as infinity. Okay, so what is XC now? XC equal to 1 by 2 pi FC. 1 by 2 pi FC, that is infinity. So 1 by infinity equal to 0. So what about the capacitive susceptance BC? 1 by 0 is infinity. So capacitive susceptance is infinity here. So BC is infinity. Here BL is infinity. So F is less than FR, inductive susceptance predominates, and F is greater than FR, capacitive susceptance is predominates. And when F is equal to FR, both the susceptance are 0. Net susceptance equal to 0. So next come to the option. When F is less than FR, inductive susceptance predominates. Correct. The current lags behind the voltage. Always the inductive reactance or inductive susceptance, current is lags behind the voltage. And power factor is the lagging power factor. So A is correct. And B, when F is equal to FR, net susceptance equal to 0. Correct. Net susceptance is 0. The admittance is maximum. That admittance is, not maximum, minimum. That is also correct. Admittance is minimum. And impedance is maximum. In this point, impedance is maximum. Correct. At FR, current is in phase with the voltage and power factor is unity. All are correct. The option B is correct. Then come to the option C. When F is greater than Fr, capacitive susceptance predominates. That is correct. The current lags the voltage. That is wrong. Current leads the voltage in a capacitor. Power factor is also leading. So option C is wrong. Then come to the option D. When F is greater than Fr, capacitive susceptance predominates. Correct. Current leads the voltage. Correct. Power is leading in nature. All are correct. So A, B, C, 3 options are correct. So the C is the correct answer. Next, two 12-volt batteries are being charged from 16-volt generator. The internal resistances are 0.5 ohm, 0.8 ohm for the batteries and 2 ohm for the generator. The current flowing through the positive battery terminal are. First of all, have to draw the generator. Generator positive, negative. Then what is the internal resistance? 2 ohm. And next I am going to draw the battery. The battery also having the internal resistance 0.5 ohm. And next the third battery, the second battery internal resistance 0.8 ohm. And next I have to connect this. What I have to do, here I have to put the voltage 16 volt, here 12 volt and 12 volt. Have to consider the node voltage is V. All the voltages are flowing, currents are flowing away from the node V. Okay, how to write the equation? Here the current is inverse. Current is inverse. So assume direction that is opposite to the actual direction. So how to write the equation using nodal analysis? Using nodal analysis, B minus 16 divided by 2. Next, B minus 12 divided by 0.5 plus V minus 12 divided by 0.8 equal to 0. What is the step number 2? B by 2 plus V by 0.5 plus V by 0.8, and the right hand side of the equation 16 by 2, 12 by 0.5 plus 12 by 0.8. And next take V common, so 1 by 2 plus 1 by 0.5 plus 1 by 0.8, that is equal to 8 plus 24 plus 15. 120 divided by 8, 15. So that is 47. Here we have to apply the LCM here. If you apply the LCM, 0.5 into 0.8, that is 0.4. Here 2 into 0.8, 1.6. Plus here 2 into 0.5, 1. The whole divided by multiply all. 8, 2 into 0.5, 1. 1 into 0.8, 0.8. So what is V? V is equal to 47 into 0.8 divided by 1.6 plus 0.4, that is 2 plus 1, 3. So what is the answer? That is 12.5333 volts. Next I am going to find out what the current flowing through the 12 volt battery. First 12 volt battery, next 12 volt battery, that is I2. So first 12 volt battery, what is I1? I1 is B minus 12 divided by 0.5. What is V? V is 12.533 minus 12 divided by 0.5. So 0.533 divided by 0.5. What is the answer? The answer is 1.067. 1.067. And so I2 equal to B minus 12 divided by 0.8. Substitute the value of B 12.533 minus 12 divided by 0.8, that is equal to 0.667 ampere. Okay, option D is the correct answer. Next problem. A 2 watt meters which are connected to measure the total power on a 3-phase system supplying a balanced load read 10.5 kilowatt and minus 2.5 kilowatt respectively. The total power and power factor are given by. So one of the wattmeter read 10.5 kilowatt and next wattmeter minus 2.5 kilowatt. So what is the total power? Summation of both. W equal to W1 plus W2. W1 is 10.5. W2 is minus 2.5. Summation of both will get 8 kilowatt. And next, the total power is okay. Then power factor. How to find out power factor? Cos pi is equal to cos of tan inverse W1 minus W2 into root 3 divided by W1 plus W2. So cos pi equal to cos of tan inverse. What is W1? W1 is 10.5 minus 2.5. So that is equal to 13. And what is W1 plus W2? 10.5 minus 2.58 into root 3. If you multiply this and finally take the cos, means we'll get the answer 0.334. So which one is the correct answer? The option B is the correct answer for this problem. Next, the power in 3-phase circuit is measured with the help of 2 wattmeters. The reading of one of the wattmeter is positive and the other is negative. The magnitude of reading are different. It can be concluded that power factor of the circuit is. So you have to take one of the wattmeter reading 10 and another one is minus 8. Both are not equal, that is given. And one is positive and another one is negative. So how to find out cos phi? Cos of tan inverse W1 minus W2 into root 3 divided by W1 plus W2. Cos of tan inverse 10 minus of minus 8 plus 8, 18 in the root 3 divided by 2. So the answer is cos of tan inverse of this one is 86.32. This is 0.06. So the option D is the correct answer, less than 0.5 lag. Next, in an ACB phase sequence, if BAN is 230 angle minus 20 and BCN is given by ACB phase sequence. ACB phase sequence, that is from, ACB, that is this is the sequence. That is the clockwise direction is the sequence of the this is a phase sequence. So ACB is the phase sequence. BAN is given. So BAN is 230 angle minus 20. How to find out BCN? A and C, the angle difference is 120. But this is the clockwise direction angle, there is no, so the angle is minus 120. So already minus 20 is there. You have to add this minus 20 with minus 120. So the answer is 230 angle minus 140. So option A is the correct answer. Next, consider the following statement with reference to dot convention in the magnetic circuit. If current enters the dotted terminal of one coil, the reference polarity of the mutual voltage in the second coil is positive at the dotted terminal of the second coil. This is correct. If the current enters the dotted terminal of one coil, the reference polarity of mutual voltage in the second coil is negative. Wrong. And C, if the current leaves in the dotted terminal of one coil, the reference polarity of mutual voltage in the second coil is positive. Wrong. And D option, if a current leaves in the dotted terminal of one coil, the reference polarity of the mutual voltage in the second coil is negative. That is correct at the dotted terminal of the second coil of the statement. So answer A and D are correct. Option B is the correct answer. Thank you. Have a nice day.